Good morning, everyone. Thank you for joining. We can see we've got quite a few joiners there. I'm Guy Barkley. I'm the CEO and founder of Atmo Technology. Today we'll be talking about our noise and energy works in partnership with Egis and GCRE. We'll just maybe hang on just another 20 seconds or so because there's still some people joining. In the meantime, should we just do a couple of round of introductions? So should we start with, there's myself, Guy. We've also got on our side, Finn. Do you want to introduce yourself?
Hi, everyone. So I'm Finn. I'm lead data scientist here at Atmo. So I did a lot of the modeling and technical work on this project.
Lovely. Thanks, Finn. And then we've got James facilitating today.
Hello, everybody. I'm James. I'm a product technical support engineer at Atmo Technology and supporting today with this webinar.
Lovely. Thank you, James. And then we've got Amy from Egis.
Hi, everyone. I'm Amy. I work for Egis, a civil engineering company, and I'm the ESG director, so I've been helping lead the energy from a rail perspective.
Lovely. Thank you, Amy. And then from GCRE, we have, should we start with we've got Rob Thompson.
Yeah, morning, everybody. Rob Thompson. I'm the Director of Implementation for GCRE.
Lovely. Thanks, Rob. And then we have Robert Wasson as well.
Morning, everybody. Robert Wasson, and I'm the Strategic Energy Advisor on the project.
Perfect. Thanks, everyone. Right. I think we're good to get going. Like I said, this is a project between Atmo, Egis, and GCRE. We'll get into the site and the team and why we're doing these works. A bit of background context. This is an Innovate UK funded project, so thank you to them for their support. We'll jump into the site. GCRE is the Global Centre for Rail Excellence being built in South Wales. It's going to be the first net zero railway and one of the important pieces there is about energy being generated on site. And Rob and Robert, please do feel free to jump in at any point. I know this is your baby. It's going to be have a double loop, so 2 loops on site for testing infrastructure and high-speed locos. Will incorporate things like regenerative braking and Rob, I think this is your world on sort of what the loops will. Do you just want to give a high level view?
So a high level view of that then. So we'll be constructing 2 7-kilometre loops, one for testing infrastructure. So anything that goes on the railway, whether that be new sleepers, new rails, new overhead line equipment, signalling equipment, etc. And the other loop then is for testing rolling stock, so new trains which need to do a period, something like 1,500 hours each of fault-free running to iron out all the kinks, as it were. As well as that, we'll be constructing a maintenance depot for maintaining those trains that are on test, as well as our own, as well as some storage sidings and what we call reception roads, i.e. ready for trains going out onto test. The site is linked by the Neath and Brecon branch line, which runs down to Swansea, and that'll be the main access for trains coming onto site. We'll also be able to take sites from road-borne vehicles, especially those of sort of European gauging, because the site itself will be gauged to allow for the testing of European trains. The plan is, as Guy's hinted at, that we want to be able to generate as much of the energy as we need from the site itself and also from a neighbouring wind farm, so that we will be the first net zero railway in operation. Obviously, if the wind doesn't blow and the sun doesn't shine, we'll still need to import electricity, but that we aim to be a sort of net exporter over the life of the site, and we will have sleeved PPA agreements with green energy to allow us to make sure that we're achieving our net zero targets.
Perfect. Thanks, Rob. That was a really good overview. Yeah, Finn, can we jump into the team? Yeah, perfect. So Atmo, to give a quick introduction of who we are and our capabilities. So we're an environmental and safety data company. So air quality, noise, that's our bread and butter. We, as context for the energy side of things, we built a model with Network Rail to help manage and optimize the renewable strategy there. So with some of their depots where they had solar power, and we're working on the business case for batteries, because there was no battery storage at the time. So optimizing what size of the battery should be, and yeah, and potentially more solar as well. Whereas with GCRE, it's a blank canvas. There's lots of possibilities in terms of how energy can be generated and how it can be stored as well. Yeah. And then on the noise side of things, yeah, lots of expertise in gathering noise in across various sectors. And Amy, yeah, but please do introduce Egis as well.
Yeah, of course. So Egis, as you can see on the slide, we've been working in rail for over 50 years, and that's over 12,000 kilometres of railway lines. If we think about it in the context of the UK, Egis are working on the Old Oak Common station that's outside London, so going for BREEAM outstanding, so from building a depot and constructing that. We also built Paddington Station and the Elizabeth line as part of Western William and Partners, who are part of the Egis brand. And then also we do, I guess you call the boring everyday project management work as well, which I guess understanding the commercial aspects with rail as well are really important when we're looking at a project like that. So it's exciting. I mean, Rob, you did a great introduction to the site, and this should be exciting for the industry and something that we should all be promoting. So it's good to be part of the project.
Perfect. Thanks, Amy. Yeah, so we're going to. I'll hand over to Finn in a second, who's been leading on the energy modelling works. But yeah, just to give an overview of why we're doing it, and why it's important for the site. So there's lots of potential variables in play. So we talked about the different types of energy generation. Wind, solar. Obviously, there's the grid there as well. But the site wants to be net zero. And there's different options for storage. Various sizes of battery could be deployed. There's been initial feasibility studies into things like super caps. Yeah, I know Andy Doherty can't join us on the call today, but even looking at mechanical storage, it's a test site. It can try new things. Yeah, the reason why some of those super caps and mechanical storage might be of interest is because on the test loop, depending on how fast the train's going, every 90 seconds or every couple of minutes, you'll have a charge and discharge from the trains accelerating and then braking and using regen. So can we, or can the site capture some of that regen, which could be in the high single-digit megawatts, so quite large loads? Can they be captured without having a battery that's large enough to be able to handle those loads? So that's some of the variables in play there. So there's some context around the business case and the battery storage, and obviously there's a CO2 story as well, because if you deploy a large battery, there's a capex, there's a CO2 cost to that as well. Robert, I can see a raised hand there.
Yeah, just so I don't want to interrupt you, Guy, but I suppose just a very quickly a bit of wider context here. So I suppose this is it's a very important piece of work, this actually, because this is going to inform I suppose the role of decarbonisation of transport, which has a huge impact just on how UK generally is going to deliver its climate change ambitions. So I mean that the very big ambitions for the government's Clean Power 30 plan and beyond, and electrification of transport is a huge part of that. So Rob and yourself have touched already on the whole question of trying to get optimization of between the intermittency of renewables and train loads, traction loads, and then also that question of regen and making sure that we're not wasting that energy. So it's a really interesting technical challenge, and it's also an economic challenge as well, because the storage and other technologies to try and make all of this work don't come at zero cost either. So it's a fascinating piece of work that the team have done. It's going to be important for future research, and of course it's exactly the kind of R&D that we're set up to do in GCRE. So well done to all of the team, and just look forward to questions that people might have in the next hour or so.
Brilliant, thanks, Robert. And so I'll hand over to Finn in a second. We've only given Finn 3 slides for both of energy and noise. I know that Finn could talk for at least an hour, probably on each slide. So if you do have any questions, please do raise them in the session. Please do reach out to any of the people on this call afterwards. But yeah, I'll hand over to Finn.
Sure. Thanks, Guy. Yeah, you might have to start waving frantically if I'm diving deep into the data science rabbit hole. But I'll try my best. So I'll talk just essentially about the methodology we used. And so just looking at energy, first of all, there's sort of a few constituent models that we then combine to build a larger model of a broad picture of the site. So we've got the solar generation model, and that takes in what you might expect. So your location, where you're going to put the solar panels, the topology, the size, area, etc., and then weather. So we look at a year of weather data and solar irradiance and all the rest, and we get what the solar production is going to be. And then we do something very similar for wind. You look at the number of turbines you have access to, what model they are, what height they're at, and again the wind speed and direction, etc., etc. And we output what the power generation would be. And then, the traction load simulation. So we built a model sort of from the ground up to model what the draw would be from different traction load scenarios. So what this one takes in is essentially a schedule. So GCRE can tell us that we'll be running this type of test, for example, an acceleration brake test for a high-speed train, something like a Eurostar class. And then we can model, given the gradient of the track and its weight, etc., what its traction load will be. And then we combine that with all the sort of background processes on site. So that's stabling, the depot, offices, data center, all that kind of background load. And that varies depending on what time of year it is, how much heating is being used, etc. So then we combine them all together, and you get a sort of a view like this. So you can see here the purple line is the traction load, and it's kind of very distinctly split into a few different scenarios. So you can see here full acceleration brake testing looks very different to what mileage accumulation might look like. So we had conversations with GCRE of what the average week might look like, because this all has a huge impact on what your optimal renewable situation is going to be, is what your actual load is going to be over a whole year. So we then combine that with obviously the renewable generation, the base load, and we then can get a whole year picture of all the energy flows on site. And so that looks a bit like this. So we then run that simulation hundreds and hundreds of different times with different parameters. So, we can increase the area of solar panels from, a few square meters up in increments of a few square meters until you reach your theoretical maximum that you have available for solar panels. Similarly with wind, you work out the theoretical maximum number of wind turbines you have, and then you test each scenario with 1 wind turbine, 2 wind turbines, etc., etc. And then we input cost parameters as well. So what is your price of purchasing electricity? What price are you going to get when you sell back your electricity to the grid? And the CapEx cost for installing all of this. And then we run it as well with many different size of batteries. So you can imagine there's a lot of different options here. A few combinations come together. And then eventually Lorenzo and I are leaving a computer running all night, running hundreds of simulations. And then we compare the costs of all of them, and we arrive at, given the parameters we've got, the optimal situation. So that's really handy. It allows us to sort of verify some other things as well that GCRE might find useful when they're talking to utility providers, like what your peak export might be, because you can't just suddenly chuck, tens of megawatts back into the grid, and your peak draw, etc. And these are all things that GCRE needs to factor in when they talk to utility providers. I don't know if there's anything you want to add, Robert, about how we use the results.
No, I don't think so. I think you've covered that well. Thanks.
Great.
And then I've just seen we've got Andy Doherty on the call as well, so he's CTO for GCRE. Andy, do you want to do a quick introduction and add your perspective to the energy modelling as well?
Yeah, good morning. I'm Andy Doherty. I'm CTO for the GCRE and been around the railway a little while. I'm not sure I have much to add other from what Rob and Robert have introduced, but I think this quite well describes or examples the swinging traction loads of a typical railway. And of course, perhaps our railway is a little bit more aggressive in that respect because there's only a small number of trains running on it. So I'll let you get on with the discussion, and we can sort of make some observations at the end.
Great.
Thanks, Andy.
Yeah, thanks, Andy. Yeah, I don't think there's much more for me to add. And I guess looking forward, we've built this really useful model, and as specifications change, we can then rerun the simulations and check, has the optimal situation changed at all? Or, as we get better energy price forecasts, we can check, is the optimal scenario we had in the past still the optimal scenario we're going to have in the future, et cetera, et cetera. Guy, I might hand back to you as well to look at the next steps.
Lovely, thanks, Finn. Yeah, so I'll talk through a couple of the next steps, and then I'm keen to bring Amy as well in as well, because to give an overview of the wider industry. But yeah, just following on from what we were saying there, there's a significant business case piece. Looking at cash flow down the line as well, because these are long-term decisions. There's a significant capex cost. Significant costs for installing installation of solar or batteries or additional wind capacity. So and then we're even looking at things like discounted cash flow. So looking decades down the line, what's the long-term implications of that? And as Finn just alluded to there, as the planning progresses for GCRE, we're currently looking at quite a large spectrum of potential outputs, but over time that will converge on fewer, more likely scenarios. And so the tool's built as quite deliberately as a ground-up model, so that you can just quickly put your new latest variables, the up-to-date information into that tool, and you can run it for a particular scenario. So I think that'll be a really useful tool as the planning progresses. But I'll hand over to you, Amy, just to give your perspective on the wider rail industry as well.
Yeah, sure. I mean, Robert, you put it very succinctly, didn't you, that this isn't just a one-off. This is looking at the whole, how do we decarbonise the transportation sector generally? I mean, we only have to look at what happened with Heathrow, was it last week, with the fire, that actually from a local level, the benefits of understanding and the energy security we need on key infrastructure pieces, not just in transportation, but in general, is huge, and the commercial impacts that downtime causes. So I think for me, this model provides the benefits of making really good local informed decisions. How much money should we spend on solar? How much storage do we need from batteries? How much revenue can we make if we proportion this part of our land for a wind farm, for example? And often when we're all chasing for net zero, which we all are, these decisions are very complicated and mind-blowing. So Finn, when you showed it very simply, you know, what the little bit that solar does, the bigger bit that wind does, we need that full picture to make an informed decision, don't we? And then when we think about the wider railway industry that we're all wanting to decarbonize, you know, what's the best form for traction? What should, you know, substations look like going forward? I mean, this is the test bed for GCRE, isn't it, of what this should look like? So, I mean, it's really exciting. And I think one of the challenges we discovered, and something that maybe the industry should come to as a whole, is getting that really, that real detailed actual traction data, because we could see how spiky it was. And when we're looking at regen, how we could utilize that to make energy for local communities if we're thinking big picture. So I think this, hopefully the output of this will help the industry make a really good innovative decisions. You know, what's going to happen with electric car batteries once they're end of life? Are we going to start using those? And I guess that's something that could go into the model further down the line. But no, exciting.
Brilliant. Thanks, Amy. So now we'll jump into noise. So the context for this is so the GCRE is an ex-quarry. It's up on top of a hill. There's a potential to channel. Well, I think in the past, you know, Rob, correct me if I'm wrong, but I think, you know, some of those loud, you know, quite significant mining activities could potentially channel down the valley, and there was effects from the topography. Now the GCRE test site should be, you know, quite a lot quieter than the quarry, so it should be a, you know, net benefit for the communities. But there's still you know, neighbours to consider, and I know the site's very cognizant of being a good neighbour to those communities.
Yeah, shall I just jump in there a minute, Guy?
Yes,
just add a bit of context. So the site was a former open cast site, operated 16 hours a day, sort of Monday to Friday, worked a Saturday morning as well. We had a 24-hour-a-day presence, with an awful lot of earth moving taking place, 100-ton dump trucks, 300-ton excavators. Noise was a constant issue, especially when we were above ground moving materials. We've now sort of done the bulk of that work, and the site's largely been quiet for the last 3 years. So we have some pretty stringent noise conditions as a part of the GCRE planning permission, and we want to be good neighbours. So we are acutely aware of the issues that that's going to bring us, both during construction, which people kind of live with because they know it's short-lived, but during operation, we need to make sure that we have accurately predicted what those noise conditions are going to be, and being able to design the mitigation to be able to minimise that disruption to our neighbours, and obviously our operations. If we're getting constant noise complaints, then that's going to lead to a problem for our operations. So that's the kind of context of this. And then Guy and the team have done some work around, I guess it's kind of the first step really in doing a little bit more detailed modelling of noise. There's obviously plenty of software systems that do it, but this is kind of taking real world data and being able to use that in a more positive way, I think, to inform the modelling going forward.
Thanks, Rob. Yeah, so you talked about those boundaries, and one of the things we do as a company is you know, we can look at exposure to staff as well, so the health and safety aspect, and then for this site particularly, there's going to be potentially lots of cuttings around the site, and there'll be potentially bunds and earthworks designed to protect those neighbours. So you know, we're part of these works is, you know, proof of concept to how can we optimize you know, the profile of those bunds to you know, shield neighbours from noise at source where applicable, but also, you know, there can be a business case for you know, things like the earthworks, where you deploy the earthworks, or the cuttings, and also, you know, we can do analysis on different types of noise attenuation barrier, and you know, going forward, I think, we could even look at things like the effect of tree lines and things where there might be sort of secondary benefits to the community in terms of visuals and sustainability. So I'll hand back over to Finn, who can take us through what we've done on noise.
Sure, thanks, Guy. So the methodology we used for noise was essentially we set up some noise emitters where the test track is close to where the test track is going to end up being. So you can see these blue diamonds here. And then we chose some sort of sensitive boundaries that are close to neighbors. And we set up a series of noise monitors measuring a variety of frequencies, starting at the boundary where the nearest resident is, and then also moving closer towards the noise emitter so we can work out how the noise attenuates over distance. And then, so we did a baseline, and that's without any sound coming from the emitter, and we compared that to previous noise studies that had been done. And this was really important because, we worked out that a lot of the time the general traffic noise was of much greater concern. And then we chose 4 different frequencies to emit a noise from the emitter. And those frequencies were chosen to represent the noise we expect to be coming from the track. So you can see here the 110 hertz, that's stuff like track noise and vibrations traveling through the earth. The 320 hertz, that's like a train horn, engine noises, and also like screeching brakes, the highest frequency there. So we then tested at each of those receptors. We then tested all of these different frequencies and also at a emission volume that we expected to replicate as close as possible what a train might emit. And then this gives GCRE essentially, real world data of where their most pressing boundaries are. If they have plans to put noise attenuation barriers in certain areas, they can really make sure that they're focusing their efforts on the ones that are going to cause the biggest increase from the baseline. So some areas have such high, background traffic noise that the screeching brakes is not really going to cause any noticeable effect. We then look.
Sorry, if I can just add a couple of disclaimers there as well. So when
Sure.
we were releasing those noises, we did inform neighbours ahead of time. We did a communication plan with the support of GCRE. There was a couple of slight grumbles before we did the testing, or you're going to be releasing beeps and things like that. And then when we actually did the testing, no one noticed. And then I think there was a question afterwards about when are you going to start the testing, but we'd already done it. So we did put a lot of careful thought into not disturbing neighbours in pursuit of not disturbing neighbours, if you know what I mean. But yeah, I'll hand back to Finn.
Right. Yeah, thanks, Guy. So then we tried to look at the efficacy of different noise barriers. So GCRE has a few test noise attenuation barriers on site already. And so then we did something very similar. We looked at a baseline noise level, and we also then tested putting a speaker on a flat piece of ground and measuring the noise at various distances from the speaker without any barrier. And then we compare that to when we actually put the barrier in place. And so you can see, at source, 95 decibels each, and then immediately after the barrier, that's down to 58 decibels. Now, a lot of that is just noise naturally attenuates over distance. But in this graph here, we compare it to what the noise levels were when there was no barrier in place, and we can see that there's an 18 decibel reduction immediately after the barrier, and then that trails off over time because as you can imagine, the noise waves can sort of bend around the barrier, and also you start approaching what the natural noise attenuation over distance would be. So we tested for 2 different types of barrier, and then that gives us a picture of if noise is an issue here and we put this type of barrier there, is that we then have the data to back up, does that solve the issue essentially? We then also looked at earth bunds. This was sort of not quite in the initial scope, and we sort of tacked it on as a hurried thing on the end. So this is more a proof of concept, but we definitely want to go back and do some more testing like this. But this is very similar. Essentially, we put the emitter behind the bund essentially, and then measured the noise levels after the bund, with very similar goals in mind of working out, you know, if noise is an issue here, if I put an earth bund there, is that going to solve my issue? Yeah, I might hand back to Guy.
Lovely, thanks, Finn. Yeah, so in terms of you know, next steps, you know, as a company, we tend to go for real-time data where we can. So you know, discussed with the site about as the site progresses, you know, one of the things we could do is so rather than just take those snapshots of, you know, compared to an emitter, we could put real-time sensors within the site boundary and at the site boundary. And so what we get there is real-time source apportionment. So you can understand and build an audit trail as to, is the noise being produced by site, or is it neighboring, you know, is it local traffic and other activities as well? So, you know, we can build that evidence base for the site to say, no, it's not us, there are other sources of noise around as well. Because, you know, sometimes sites can be a lightning rod for complaints. So if we can build that evidence base to say that sites are actually performing well, that's obviously useful in terms of yeah, those communications. And then, yeah, as we discussed as well, you know, informing further noise modelling using that data, and yeah, as Finn mentioned, we did some bonus testing of bunds and at the end. But you know, I think if there's going to be significant earthworks and cuttings and things like that, and you know, that's something we could set up. You know, yeah, really control those variables and do a tight study around that. But yeah, I'll invite. Yeah, Rob, was there anything you wanted to add to that?
No, I don't think so. I think that it's as I said earlier, it's kind of the first step on a road that will hopefully develop and give us a lot of real-time data that can be fed into the model properly, rather than just assuming actual levels. Yes, assuming made up levels or manufacturers levels. We can actually test in real time. So that's going to help us design our noise attenuation, noise mitigation for the scheme going forward.
Brilliant, thanks, Rob. And I just remembered that Lorenzo also did some work on the effect of wind on noise propagation as well. So, you know, one of the things we often do for sites is incorporate real-time, you know, ambient conditions, wind data, so we can look at the effect of that. If there's prevailing wind, it might mean that some neighbours are going to be more susceptible for a given level of noise. And again, it can inform earthworks and bunds and noise attenuation considerations. Which, you know, those can be quite significant outlays. So if we can have some data at the start to help, you know, make sure that's a data-driven strategy, that's always beneficial. I'm conscious that Andy, you mentioned earlier on, you know, potentially having a bit of a wrap up, and you know, we can have a bit of discussion. Is there anything you wanted to tap back into?
Well, as Robert just said, you know, we're trying to design this site to be a unique site with a incredible capability, but we're also trying to respect our local neighbours. We believe it's going to be of great value to the local community, but it's not of great value if it's actually an irritation at the same time. So we have to find a way of being, you know, as good as we can be. The reality is we're running, in the main, electric trains. They're running at 180 kph. So the issue we're managing is a mechanical management issue, noise issue. We won't be running fast enough for having any significant dynamic type noise creation issues. So most of the issues can be managed low down on the track by barriers or bunds, etc. And in fact, the only other thing that we're going to have to consider carefully is when we maintain and how we maintain too, because that probably might be some of our worst cases, but they are very intermittent. And if we carefully schedule that, I think we can avoid issues there too. So from a noise point of view, this is a good siting place for us to consider for the future.
Brilliant, thanks, Andy. Amy, was there anything you wanted to add in on noise? And I know energy is more your specific area, but I know Egis has a a team that does noise as well.
I don't know if I've got anything else to add, actually. I think, Andy's message about the importance of the site and the perception that can be changed if you do become annoying, noisy, that we're going for this innovative, one-in-a-kind site. It needs to be kind and work with the community as well. So I think that's why, this relationship with the communities is massively important, isn't it? So that they're aware of what you're doing and the changes you've maybe made because we looked at those buns and those images of really communicating the changes in the way that the site's been thought of. And that all comes from the data, doesn't it, of knowing the impact and then making mitigations where you can. Yeah,
absolutely. Thanks, Amy. I can see we're on time, and I've had a nudge that there's a couple of questions. So, James, can I hand over to you, and do you want to relay any questions to the folks on the call?
Yeah, sure. So the first question is on the noise project. Simply asking, were there any complaints from neighbours? I guess we can ask if it was before implementing the project or during the project as well.
No,
Rob.
Well, I guess we had a lot of noise on social media following. We took the kind of proactive decision to inform the local communities that we were undertaking this noise testing, and that created a load of noise on social media with the usual sort of negative press you'd expect. But as Guy alluded to, we actually then had social media posts afterwards going, has this actually taken place? So in reality, the noise source didn't generate any great issues. It was relatively short-lived. I think they were a minute at a time, something of that nature. But we just thought it was the right thing to do, is to inform the local community. So that the project itself didn't generate any noise complaints, just a bit of noise, if you like, on social media.
Lovely, thanks, Rob. I didn't want to speak for site, but that was my hope and understanding as well. But yeah, we were very careful internally. We put in a plan for mitigating against any disturbance to the community. So I remember there was feedback. I think there was going to be a funeral procession, wasn't there?
There was a funeral, so we did suspend operations for an hour while the funeral took place. So,
yeah. So we put a hard no to any testing during that, because obviously we want to be respectful. And I think the team was on the other side of the site as well, and it's a couple of miles across the site. And again, I know James and Linda, you were very keen to minimize the duration of any beeps. So I think it was it 15 seconds or a minute or something maximum. So it was very short duration, and it was only for the purpose of this feasibility study, just to understand how noise propagates through the valley, essentially. So for any further real-time work, that wouldn't be needed. But like I say, it was an Innovate UK project, so there was scope for it's not something Atmo would normally do, is release beeps, but we felt, given the context of the site and the fact it's on a hill with valley, flanked by valleys and nearby villages, that the benefit would outweigh any disturbance to the community. James, were there any more questions?
Yes, we've got another one on the energy project. Does the model incorporate C ratings from batteries? Because smaller batteries can constrain the power loads.
Sure. I mean, I could answer that. The answer is yes. It's definitely something we looked at, and this is one of the primary sort of parameters you look at when you're comparing supercapacitors to a sort of standard industrial battery. So I guess for those who are not so deep in the energy storage weeds. C rating essentially talks about how much power you can instantaneously absorb as a battery. So if you're a 100 kilowatt hour battery and you're a 1C battery, that usually means you can absorb 100 kilowatts at any moment of power. Now, if your C rating is lower, you still might have the same capacity, the total fullness of the battery, but instantaneously you can only handle half of that power sort of per second, you could say. So it's definitely something we looked at when we compared a few different ones, and also that impacts the cost of the battery as well. A high C battery is more difficult to engineer and ends up being more expensive. So yes, short answer, yes, it's definitely something we looked at. It's quite an important parameter. Yeah, Robert, I see you've got a hand up.
Yeah, just to pitch in as well. So I think, as storage technologies develop further, and there's a lot of research money going into long duration energy storage, and that's going to be very interesting for all sorts of applications, including rail as well. So I think studies like this will help to inform those potential future applications as well. So it's not just it isn't just the current forms of predominantly lithium ion type battery storage, but also different technologies that will be used for potentially in the future for long duration storage as well.
Lovely. Thanks, Robert. And Andy, I know this is potentially a very, very deep rabbit hole and something that you've given a lot of thought to, but I know there has been a bit of discussion around, put in other forms of storage, maybe in sequence, so you can handle those higher loads and, smooth them out. Do you just want to give a quick overview of your perspective on that?
Yeah, so railways traditionally, they use very spiky loads. Trains are pulling lots of megawatts of power and then regenerating lots of megawatts of power. So they don't naturally connect to a renewable very easily. And part of the purpose of the site is to understand that. So our aspirations to move as a world, as a society, as GCRE then to net zero, of course, costs money. It's not something that can be done. We have to find a way through this as for society. So we see GCRE as a place where we can test and develop some of these things. But clearly, there is a price for doing so. So managing that, understanding the problems, being able to scale what that actually is in reality of energy, as opposed to the spikes, i.e. what's the energy under the curve of the diagrams that you were showing earlier, it's very useful to see the scale, because now you can start saying, okay, so scale equals money eventually, and on what is affordable, what isn't affordable. So it's a good siting plan and very helpful for that. But the way of doing it is not yet clear. There are emerging options, as Robert says. Battery technology is developing all the time, but we do have this little problem that solar's running at DC, batteries are running at DC, and our traction system's running at 25 kV single phase AC. So we have to connect the two up, and that's not cheap. So it's actually useful to understand the problem, but it's also useful to us to understand the siting of what can be achieved, and then we can understand whether we can how best to achieve that. Because the higher the capability of the battery or the flywheel or the super cap, inevitably the higher the price for it. So we have to be, I don't know, going into this with our eyes open.
Yeah, thanks, Andy. And I might just add, because that sort of tees up very nicely that, like you say, there's so many different options to consider, and especially with the energy problem, essentially what you have is you've got hundreds of different parameters you're trying to optimize over. And that's very hard for a human to think by sort of step by step. If you were only looking at one parameter, you might be able to say, right, okay, we want to increase the battery until we get just the right size. But you can increase the battery, you can increase the size of solar array, you can increase the number of wind turbines, you can change the battery C rating. So it's a huge multi-dimensional optimization problem, essentially, is what Lorenzo and I might call it. And that's why, you know, a computer is very good at that sort of thing, much better than a human working it out in their head.
Lovely, thanks, Finn. And James, were there any more questions?
Not that have been raised in the chat, but if anybody does, please make yourself known.
Speak now for a hold your peace. If you do have any follow-up questions, please do reach out to ourselves at Atmo or the GCRE team or Amy from Egis. Just final thing for me. Thank you for attending. Thank you for the team at Atmo that's been working on this. Thank you GCRE for hosting us and being a really good partner. And Egis as well. Thanks Amy and the team at Egis for supporting the project. I think we're on good time. We've got the 15 minutes there, so have a lovely lunch and a good afternoon. Thanks for joining. Take care.
Thanks, guys. Cheers.
Bye, everyone.
Cheers, everybody. Bye-bye.
Bye.